Okay, so let's cover some basic math and some terms you need to know for this course. We'll look at this definition here of the word force. Force is the energy or the strength used for movement. Okay? A Newton is a unit that measures force. So let's jump ahead in time to where we get to the next guy called joule. Amount of energy transferred when a force of 1 Newton is applied to an object for the length of 1 meter. Okay? The energy for the movement, and it's measuring that force for 1 meter. Okay? Now, what is a watt? A watt is in 1 second. So let's pull this together. We got a little guy here with the mask, and we have a 1 kilogram weighted ball. By knowing the density, the weight of the ball, we can measure or have a known of how much strength or energy it will take to move that ball. A distance of 1 meter in 1 second. A 1 kilogram ball moving 1 meter in 1 second, that energy it takes to do that is a watt. Now, what does that mean? How does joules and watts work together? Well, look at this. Here's an example. 1 second, 10 watts for 1 second equals 10 joules. $10 watts used for 5 seconds equals 50 joules. The reason we're using the word joules here is we want you to see how much energy is being used. But notice this is the word here that you'll be using for the rest of this chapter, watts. But I just wanted to give you a little bit of a breakdown. Yeah, my little guy's got his mask on because he's being the social distance thing over there. You see him? He's got his little mask on. So, here you go. So when we're dealing with a watt, a measure of how much energy is flowing, let's convert that into like mathematical terms. Code word number 3 is 3. 1 volt times 1 amp equals 1 watt. Did I lose you? 1 volt times 1 amp equals 1 watt. So 120 volts times 0.5 amps equals 60 watts of energy flow. Amps times volts equals watts. Now, you were given that sheet when you first got here. I can give it to you again when you come to lab this week. Let's see, I got it right here. And you might want to scam over this thing. Scan over it, not scam. Who said scam? Not me. Scan over it. So it says, I know this is the boring part of the video. I'm looking for something. All right, I'm gonna have to give up on it. I can't find it. I'm at failure. One last page. Of course it'll be on the last page I looked for. And it wasn't, but it's in here somewhere. But I'll give it to you, but it's the chart that shows you volts, amps, ohms, and how to calculate them. It's pretty easy to understand. But Now, when we talk about watts and we get into the thousands, we get into the word of kilo. You know what that means. 1,000 watts equals 1 kilowatt. 2,000 watts equals 2 kilowatt. 3,000 watts equals 3 kilowatts. Did you get that? Okay. So as we continue on the watts, let's get into some more terminology for the watts, okay? What is a watt hour? 1 watt times 1 hour equals 1 watt hour. Did I lose you? You need me to say that again? 1 watt times 1 hour equals 1 watt hour. Go ahead and write that down. Now, that doesn't mean it took an hour to use a watt. That just means 1 watt was used within an hour. Got it? If you have questions, you can text me or ask me, okay? Now, let's use some examples of this. I like examples because it helps explain. 100 watt light bulb. You go to the store and you buy you a 100 watt light bulb. 100 watts in 1 hour equals 100 watt hours. 100 watts in 2 hours equals 200 watt hours. Now you can see why I said 1 watt in an hour doesn't mean the watt was used for an hour. It means 1 watt was used in an hour. 200 watts times 1 hour equals 200 watt hours. Simple math. What is a kilowatt hour? Kilowatt hours are how you are charged for your electricity. 1,000 watt hours is a kilowatt hour. Your electric bill may say 0.12, which is 12 cents, or however your electric company decides to charge you, but it's by kilowatt hours, okay? So 1 kilowatt hour equals 1,000 watt hours. Kilowatt hours. Kilowatt hours. kWh's. So let's break this down, because some of you are auto guys, into an example of a car. A kilowatt is the speed, how fast it can go. The watt hours is the mileage, how far it can go. So we have power and speed, energy, and we have the distance it can be used. So that's how we break up kilowatt hours, okay? And the code word for this fourth code word is 8. Now I'd like you to do some practice math problems, okay? So let's look at these. Work these out by yourself. 240 volts times 100 amps. What's your answer? 200 volts times 115 amps equals 220 volts times 20 amps equals, and 220 volts times 40 amps equals. Now I'll give you some time to do this. The best thing for you to do right now is pause it. Do the math, pause it, do the math, and then come back for the answer. I'm gonna give you 5 seconds to pause it. Bam, here's your answers. So what we have for the first one, 240 volts times 100 amps equals 24,000 watts, written as 24 kilowatts. 240 volts versus times 115 amps equals 27,600 watts, or 27.6 kilowatts. 220 volts times 20 amps equals 4,000 watts, or 4 kWs. 220 volts times 40 amps equals 8,800 watts, or 8.8 kilowatts. And one reason I had you do this is because 4 kWs, 8 kWs, 10 kWs, 20 kWs, we're in the area of residential strip heaters in homes that people use for electrical heating.